Good morning everyone. Today we are going to discuss about what will happen if we connect to capacitors by wire, how the charges will redistribute, what will be their common potential, and whether there will be any change in the energy. So first consider two parallel plate capacitors. Say this one is of capacitance C1 and this had charged Q1 and the potential difference across the plates is V1. And we have another capacitor, say C2, charge is Q2 and the potential difference across them is V2. Now say this plate is positively charged and this one is negatively charged, and for similarly here the cases. Now suppose we connect this positive terminal with this capacitor and positive of this capacitor by a wire, and this one also by a wire. So now what will be the charges on them, what will be their common potential? These are the things we are going to find out. Now once we connect these two like this, there will be charge flow. Now assume that the charge on the C1 is more than on the C2. So charge will flow from this direction to this direction, and after certain time, when both the capacitors will have a same potential, the charge flow will stop. So when they are disconnected, we can write Q1 equals to C1 V1 for first capacitor and Q2 equals to C2 V2 for the second capacitor. Now when they are connected, the total capacitance will be C1 plus C2, and of course there will be no loss of charges, so the total charge will remain constant. So if the common potential after they are connected, say, is V, common potential, so you can write for the combination total charge Q equals to capacitance of combination multiplied their common voltage. Now since the charge remains constant, you can write Q equals to Q1 plus Q2 equals to C1 plus C2 into V from this equation, and now put the values from there. C1 Q1 equals to C1 V1 plus C2 V2 equals to C1 plus C2 into V. So V will be equals to C1 V1 plus C2 V2 by C1 plus C2. So this will be the common potential across the capacitors. Since the capacitance of an individual capacitor is independent of its charge or potential, so now the charge on this capacitance, say, is small q1, which is q1 equals to C1V. So you can write it as C1 into C1V1 plus C2V2 by C1 plus C2, and similarly on the second capacitor will be C2V, so this is C2 by C1 plus C2 to C1V1 plus C2. So these will be the charges after the redistribution. Now let us find out whether there is any change in energies. Now when they were disconnected, the total energy of both the capacitors were EY equals to, for the first capacitor, half C1V1 square, and for the second capacitor, half C2V2 square. So this was the initial energy, and after connecting, the final energy is half. This is the capacitance of the combination, and they have a common voltage V. So this is the voltage. So this is the initial energy and this is the final energy. Now let us find out whether there is any change in energy. Now from the conservation of energy, the final energy cannot be greater than this one. It can be less or can be equal, right? So let us find out whether there is any change in energy. So delta U equals to, let us find out, Ui minus Uf. So we'll just put the values. Half C1 V1 square plus half, like this. Now we'll put the value of V from this equation. So we'll get like this. Now if you calculate it, you will get a value like this. Now this term, capacitances are always positive, and this is a square term. This is also at least 0 or more than 0. So in general, delta U is positive quantity. So what we see, that initial energy is greater than the final energy, so there is some loss of energy. So whenever you connect to capacitor like this, there is always some loss of energy, and this energy is lost mainly because of the heat produced. Now here you can see that we have connected positive terminal with positive terminal. Now we can also connect in opposite, like negative positive with negative, and this is negative with positive. So in that case, the net charge will be actually Q1 minus Q2. As here it is Q1 plus Q2, in that case it will be Q1 minus Q2. And so the common potential here, you will get a negative term, and this will be minus, and again this will be minus. And if you calculate the final energy, the formula will become C1 C2 by 2 C1 plus C2 into V1 plus V2 whole square. Now again in that case, the effect will be same, that this energy term will be positive. So just try to do that on your own. When this one is positive and we connect the other capacitor in such a way that this plate is the negative one and this one is the positive one. Okay. Now let us discuss another very important topic, which is with introduction or removal of a dielectric, how the electric field or capacitance or charge or potential or the energy stored in a capacitor changes. So for that we will consider two cases. Now case 1, that capacitor is fully charged and removed from the circuit. So we have a capacitor, say it is fully charged up to potential V, and it had charge Q, and its capacitance is C. And suppose initially inside it was vacuum, there was no dielectric medium. Now since it is disconnected from the circuit, no matter what you do, the charge has nowhere to go. So the charge on the capacitor will remain same. So this is the case of when we disconnect the circuit, disconnect the capacitor from the circuit. So these are the values, and say the electric field is also E, and the energy stored is say U or whatever. Now suppose suddenly we introduce a dielectric or dielectric constant K. Now first we consider the capacitance. We already know the capacitance formula is epsilon naught if the area is A and the separation is D. So this is like this. Now with introduction of this capacitor dielectric, the capacitance will becomes K epsilon A by D or K into C. So the capacitance will increase by K times. Now no matter what, the charge will remain same since it is disconnected. Now from this formula, Q equals to CV. So suppose it was the initial charge, capacitance, initial potential. Now after introduction of the dielectric, capacitance changes to C prime and say voltage changes to V prime, but the charge remains same. So you can write Q equals to CV equals to C prime V prime. And CV equals to C prime means Kc to V prime. So V prime will be equals to P by K. So actually the potential difference between the plates will decrease by K time. So it is the case of introduction of dielectric medium inside the capacitor. Now with introduction of the dielectric medium, there will be some polarization and the electric field will decrease. Even you can tell from this equation, since E and V are proportional to each other, so you can write that electric field will also be like this. Now what will happen to the energy? The energy stored. Now we already know that there is three equations of energy. One is half cv square, the another one is half vq, and the another one is this one. Now which one to use? Now here q is constant, so it is better to use the equation where there is a term q. So either you can use this one or you can use this one. Don't use this one because both are changing. So suppose you use this one, so the initial energy say is equals to half vq, final energy is half v prime q, q remains same. Now since v prime is less than v by k factor, so you can just write half v by k into q. Now half vq is u, so this is u by k. So the energy stored in the capacitor will also decrease. Now all the cases will be reversed if initially there was a dielectric medium, you charged it, disconnect the capacitor from the circuit and remove the dielectric, everything will be in reverse. Okay, so in that case capacitance will decrease by k time if we remove it, potential difference will increase, electric field will increase, energy stored will be increased. Now let's consider the case 2 where we will not remove the capacitor from the circuit. So consider the capacitor is connected with a battery of voltage V. Say it is fully charged with charge Q and its capacitance is C. Now since it is connected with the battery, no matter what you do, suppose the charge gets decreased by somehow, it will automatically collect charge from battery until the potential difference between the plates become V again. So when it is connected with the battery, the potential difference V will always remain the same. When it is disconnected, the charge remains same. When it is connected with the battery, the potential difference will always remain same. So I can say the initial parameters are V, C, Q, electric field say E, and the energy stored is U. Now again suppose we introduce a dielectric constant. So with the introduction of the dielectric medium K, again if we use the simple formula, the capacitance will definitely increase by K time. Now as the capacitance increases, potential will not change no matter what because it is connected with a battery. So initially you can write V equals to Q by C, and no matter whatever you change made, V remains same. So after some time this will also be Q prime by C prime. So with the introduction of the dielectric, Q prime will be equals to C prime by C into Q. So this will be K into Q. Just putting the values of C prime from here. So you can see that the charge stored will be increased. Now what about the electric field? Now with introduction of the dielectric medium, there will be polarization, there will be decrease in electric field. But as soon as you insert the dielectric, there will be gathering of more charges. As a result, the electric field will become E again. So since V is not changing, the E will also remain same. Now the energy. Now here you have to use such a formula where V is constant. So you can easily use half CV square formula. So equals to half CV square initially. Now finally U prime will be equals to half C prime V square, sorry, this is square, because the potential doesn't change. C prime is K times, so half KCV square or KU. So here the energy stored will increase. Now again here, if the dielectric medium was inserted initially and you removed it suddenly, then all the parameters will change in the opposite direction. So this is it for today. These topics are very important. A lot of questions are asked from you.